Hello, I'm Lynn Langett. In this screencast, I'm going to show you how I use MindMaps to understand systems. The case I'm going to use here is a system for bioinformatics or genomics analysis that happens to run on the Google Cloud. It's called Terra.bio. I'm really going to be focusing in this screencast on the technique of using a mind map to be able to trace, in this case, where the data is on the particular cloud, so GCP in this system. So I'm not focusing on how the system actually works. This is not a training video, it's more of an architecture video. So for those of you who aren't familiar with Terra, which I assume is most people, the idea here is that we have a higher level interface designed for the end user, which is the researcher, which abstracts away the complexities of manually configuring cloud services. Those services consist of a number of GCS buckets along with clusters of GCE virtual machines which run Docker containers. And I'm going to focus particularly in this video on the data side. I probably will create a subsequent video on the compute side. And this is really primarily for my own and people that I work with on this system's understanding, but because I use this practice, I thought I would record it and share it more widely for potential applicability to your systems. So if you look at the system, it's at the level of a web UI, and you can see there are various pieces and parts. There's a dashboard, which is basically a wiki to explain the research that will be run through the system. There is a data section, which allows you to specify the data that you're going to be computing on. And there are different types of data for the data model that was created for this use case. So there's tables, reference data, other data. There are notebooks, which is a place for IPython or Jupyter notebooks to be made available. And you can see we have a notebook runtime associated with this. And then we have workflows. In this particular system, we're working with an orchestrator called Cromwell, which is an open source Java-based VM orchestrator that can run on a number of environments. In this case, it's running on GCP with pipelines to take advantage of cloud scaling, so spinning up and down machines. And the language that is used to configure Cromwell is called WDL, or WDL, or Workflow Definition Language. It's a scripting language. And you can see we have a number of workflows here. If we drill in, we can see each workflow has associated information. It has a script, which is WDL, it has inputs, it has outputs, and then we can run the analysis. So we have a job runner here. Once we click Run Analysis, we will run the analysis. We can see the results, and we can also see the overhead associated with the run in the job history section. And you can see that we have different runs of different workflows here, and those are called submissions. And if we scroll in, we can see that we can see detail in terms of whether the job execution succeeded or not, and then we can actually go into a different resource called a job manager, and we can see the inputs, outputs, the timing, we can see the results, so they're linked, you can see here, and we also then have the ability to work with a system to manage workflows. If we click Find a Workflow, we have two different systems. We have something called DocStore. We have the Broad Methods repository. If we click in there, that takes us into a separate system. And this is a repository for those WDL script files. And you can see we can click in and we can see the permissions associated, we can see the WDL, and then we can export that back to a Terra workspace. So I purposely went over this really quickly because I just wanted you to get a sense of the parts and pieces in the Terra system. So from an architect standpoint, a tool that I often use for my own understanding as well as for my teams is MindMap or MindMup. So I'll show you what the data storage on Google Cloud for the system is represented like in a mind map, and I'll come back to Terra to reference. So I colored in green the parts that are associated with what the end user sees. I colored in gray parts that are either not physically part of Terra but maybe associate to it, that the underlying user cannot see the actual data files, but they can work with them. So for example, you have the ability to clone or copy example workspaces. And the process to that is in Terra, you click a button, you review the workspace to see if the process would be applicable for your research, and then you click clone. So of course, workspaces are run by WDL files, script files. They also include JSON files for workflow configuration and TSV files for pointers to the underlying data that's associated with it. So when a user interacts with Terra, they don't see the underlying GCS bucket. They simply work at the level of Terra, and I'll show you what that looks like. So inside of Terra, if I go into the library and I go into the showcase and I go into a workflow of interest, so I'll just pick this one. I can view this. This is a read-only, but if I wanted to perform the computation, you can see here it's read-only, then I would have to clone it. So what is happening here is the underlying associated WDL files, which are here, are going to be copied into a new workspace with a new name that I can then compute on. So in terms of understanding that data flow, really I don't need to, as an end user, understand that this is stored in some GCS bucket somewhere. I just need to click the clone example, and then I will be able to compute on this. So the next aspect that the researchers would be using in terms of data would be data sets. And there's two types: reference, so things like 1,000 genomes, which are publicly available, or often restricted because they relate to human disease, and then their own research data. So you notice I've marked this as external, and it's as we'll see when we dig in, it can start external, but it can also be part of the particular workspace. So let me just start here by saying we have at the top level a number of different choices. We can work with the BigQuery service. That's where a number of these data sets have been set up. You can also, as a researcher, set up your own GCS bucket. You can create a BigQuery data set, or you can just refer to some data set that's available on the web to which you have permissions. Now, if we go back to Terra, and we go into data, you can see, again, this is abstracted to a higher level. So if I click on Browse Data, what's actually happening here is I'm getting a visual representation that I can just click to generate a filter. But under the hood, this is stored on GCS. Rephrase. The actual implementation is this is stored on BigQuery. And when I click to filter, that generates a SQL query. And how do I know that? If I click Save Cohort and I say Example, and I click Save, and then I'm going to just create a new workspace. I'll call this Example for Demo. Now inside of here, you can see it literally says BigQuery Table, and we have a table name inside of here that was generated by my clicking, which basically ran a query over all of the data that is available on BigQuery. So that is this use case here, and it's green because it's visible in Terra. Now there's another data set that's available in the Terra Data tab, and inside of the Terra Data tab here, if I click Reference Data, you can see I get B37 Human or HG38, and again, those are available through storage on Google Cloud as public data. And as I just demonstrated, once you take a look at the Terra data sets, you simply click to filter and then you import them as a cohort into your workspace, and that will create a BigQuery SQL query on that data set. Now, if you wish to put your research data in a bucket that will persist irregardless of a workspace, then a recommended practice is to create a separate bucket and assign permissions, and then you would put your input files. Now, if you're going to be using the BigQuery compute service, you may need to create a BigQuery data set out of that so you can run SQL queries across that using Terra notebooks. Also, I have found that I put image files in here, which are used in a different part of Terra. This is completely optional, and that's why it's colored in gray, but it is a path that some people choose. So once you have your workspace, then you're going to want to either write a WIDL workflow or reuse an existing one. So as with the templates for workspaces, there are workflows that you can add. And there are two places to be able to do this. You can add this from what is called the Broad Methods repository, which is a remnant of the predecessor to Terra, which was called FireCloud. And in the beginning of this video, I quickly showed that. And it's a repository for WIDL files. Alternatively, there is a public repository that has WIDL along with other workflow files for bioinformatics. It's called DocStore, and it has WIDL, it has CWL, it also has Nextflow. And the way that this works is because most WIDL files will include a pointer to a Docker image that contains the actual scripts or binaries to run the computational logic. On DocStore, you have a pointer to the Docker image in Docker Hub or alternatively Quay.io. And then on DocStore, there is a button that says Launch with Terra, and that would clone the WIDL files, JSON files, and Docker file optionally into Terra and make that workflow available in Terra as an executable workflow. So you have two different methods to get reusable, customizable, configurable workflows into your workspace. One is the Broad Methods repository, and that's using, again, an internal bucket. You interact at the level of the GUI here. Or you can use DocStore, which then that would copy those files into the internal bucket for your workspace. So speaking of your workspace, once you create a workspace, as we just did to work with our data set, then you have two buckets associated with that workspace. One is an internal bucket for your workspace files. And again, like from some of these other examples, using example workspaces or example workflows, although your files are placed there, your WIDL files and such, you don't see that bucket. So for example, if I go into the workflows and I were to create or add a workflow here, so find a workflow and go and get one, and add it by saying export to workspace. And there's no parameter configuration, so I'm going to use a blank parameters. And I'm going to select my workspace and export it. And then I'm going to go back to that page. We now have a WIDL script, but we interact with that WIDL script at the level of the GUI. We do not see the underlying bucket here. So if we wanted to interact with this WIDL script, we would go back to find a workflow, which really should be named work with a workflow. So for example, we want to edit the WIDL file. We would go back through here, and we would not go to the underlying bucket, which we cannot see. So when we add workflows to our workspace, there are underlying WIDL files. that are put into this internal bucket. When we configure our workflow, there is a JSON file that is created. And again, that goes into our internal bucket. So if we were to have configuration on our inputs, which we do not have in this particular case, then we would have a JSON file. And I'll just show you another one so you can see. So in this workflow, you can see that although, again, it's the level of the UI, we can download a JSON file or we can upload a JSON file, which is going to be key value pairs with these values in it. We then, when we would run our job, we would use the job history section. And over here, you can see that this is associated to pulling a Docker container. Docker containers images can be in a Google Cloud registry. It can be in Docker Hub. It can be in Quay.io. And there will be your Docker image, but also there will be a Terra Docker image, which is pulled, which is part of using GCP with PAPI, which is the Pipelines API. So another piece that is available to you that you do not see is the dashboard in Terra. So the dashboard in Terra is a markdown file. And you do not see, you can edit this, but you do not see this other than at the level of the UI. So the actual physical file is not something that you can get, basically. You edit through the UI. And so when you're working with this, you work at the level of the dashboard. Now, your data that you're computing on in the workspace, when you create a workspace, a bucket is created that you can see for your computational data. And it always has the name FC for FireCloud with a bunch of numbers. And this is where the data at the workspace level is placed. And how this works is this tab here. When you're in a workspace, you have these various sections, and they're really ordered in terms of use in the workflow. But I'm actually going to start at the bottom with files. And this is going to show you your files in your workspace. Now, if you click, well, first you can upload by clicking this button. If you click, you can see that this stands for copy. So if you want to copy this locally. But here is the bucket, GS, FC, blah, 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 blah. And if you go to the end of it, I copy to the clipboard and then just paste it out somewhere. You can see that that is the URL of your bucket. Now, Terra generally is trying to keep you from working at the level of a bucket, but as you'll see in job executions, it's quite common. Now, these are your actual execution IDs for your jobs. And so if you go to your job history, you can see you've got a submission ID for each job, and then you have a workflow ID. So that's where this job execution information can also be viewed. If I go inside of here, and I go here, and I click here, you can see these are, this is my workflow name, and I click in here, and I have all the way down to the script, and again, it'll preview if it can, and it's in a bucket. So at the data level, there are four aspects. So we were just looking at files. And at the file level, we basically have four kinds of files. We have execution logs, as I just was touring you through. The notebooks for IPython notebooks would be here. If you had other script files that your WDL file was calling, commonly you would put it here, or reference files like CSV. And then you would have input files that you're computing on. unless you put these files in an external bucket. So you could either put them in this internal bucket here or external bucket that is separate from the workspace. Now, why would you do one over the other? Well, inside the workspace, you don't have to assign them permissions. They're inherited, so it's simpler. Outside the workspace, you can compute on these input files on different workspaces. And also, if you were to delete this workspace, this bucket would be gone. Any bucket outside the workspace, and by that I mean like this one, this is going to be persistent, whether or not this workspace is existent. So it's an important choice when you're setting up your computation. So once you have your file situated, then you have some other options that you can use. Now, if you have set up any reference data, and that would be this data here, so this BigQuery genomic data sets, that's actually going to show up inside of reference data as a pointer to it, basically. So what I mean by that is if I click here, then I'm going to add this data that's actually underlying in BigQuery. Same thing here. So what is next? No, workspace data. Workspace data I think of as parameters. Technically it's a TSV file. So you upload or download key value pair, and you use this as input to a workflow. So for example, this is the size of memory in gigs for a particular workflow, and it's aliased as workflow.keyname, and then you can put in whatever value in here. So you don't have to use this, but it can make adjusting the values of workflows quicker than going in and manually doing it. So an example of what this looks like is you can see workspace.memory in gigabytes, and that relates to workspace.memory in gigabytes. So if I were to change that value here, it would change in the workflow execution. Now you can just click plus to add a variable here, or you can work with the TSV file. This is at the level of the UI or TSV file. In terms of tables, this is your data you're computing on. So your BAM files, your BCF files, or whatever. I don't actually have that here, but you can see that, again, this is pointing to not FC, this is pointing to an external bucket. So that's why this is a public bucket, and this one is pointing to the internal bucket, FC. And then when you reference tabular data in your workflow, you use the naming convention this dot. So this dot public bucket, this dot workspace, and I'll show you what that looks like. So you can see I'm running workflow with inputs defined by a data table, and I'm selecting the table, and I'm choosing specific rows. So that's going to run into the workflow as this dot public bucket, which will go and get that file, and this dot workspace, which will get the file from the internal. And again, just to close the loop on this, you can see that if I go to files, input.txt is actually here, but the other one is not because it's outside. So what this looks like is the workspace data, as I said, are just the key value pairs. So workspace.value, and then the tabular data is a key value pair that relates to this input file, so this dot value. So that using this table model or the workspace data is optional, but it's a best practice when you are changing the input data. Rather than manually changing the workflow parameters, you simply change the underlying TSV file, or in this case, you just change the value in the data section, and then that will change it across all your workflows that are using this parameter. So in addition to this, there's operational data, which is not seen by users, and again, internal bucket. So you have example templates, and you have GCP workspace configuration. You also have activity logs, alerts, and audits, and this is reviewed by scripts, also by people working at the Broad managing Terra, to make sure that resource allocation is not being overused. Now, in terms of job executions, if we go down here just to kind of complete the loop, once you run a job, let me just open this all up, then it's kind of hard to see right here, but once you run a job, the execution logs, as we saw, show up in files. So what I mean by that is these are the execution logs from these job history here. But you typically will look here in the job history section if you're looking for the output of the job. So first of all, if you want to see if it succeeded, you look at the UI. So succeeded, but then, most importantly, you want to see the output. And again, this is going to go to your bucket. And we just set this to standard out as an example. You can set it to whatever path you want, but it goes to your bucket. So it's a data lake pattern, basically everything operating on files in a bucket. And this is, just your results in standard out. And you can see the path here. Let me just make it bigger so you can see it. You can see here's the bucket name, and then there's execution GUID, the name of the workflow, and this particular execution, the name of the method that is running, or the task. And in this case, we ran it out of cache, so the cache copy. So if we want to look at different executions, cached or non-cached, we can just go up in the tree. Although, less and less we're going at the level of GCP. Notice there is no project. There's a lot of things that are restricted here because, again, the idea is using the Terra interface. The end user will not have to work really ultimately at all with the underlying GCP platform. They will simply run on it, but they will find everything through Terra. And you can see that's the example there. So you can see as I've gone through here, I've used this technique of closing and opening levels, which I find to be useful in architecture because, as I've said many times in different talks, from my background in business information analytics, I am well aware of lots of research that has shown that people can only process generally between 3 to 7 data points. And I'm in that group. So when I'm looking at complex system architectures, I use this mind mapping technique so that I can expand and collapse as I'm drilling into the different sections. And, I really had a twofold purpose in recording this. One was for people that I work with in the Terra system, and the other one was to share this technique of using expandable architecture to understand systems. So again, I'm Lynn Langett, and I hope you're having a great day.